Hello, and welcome back to the tutorial on types of data. Previously, in the first part of this section you learned about the categorization of data based on representation, that is, structured data, unstructured data and semi-structured data. In this video we will move on to categorize data based on its variety. The different varieties of data have enormously developed since the past 2 decades. As the technology began to share an important part of our daily lives, it brought with it innovation, and following it came data that was completely new to the world. Nobody knew a GIFs a decade ago or about MP4 formats back in 90s. Precisely speaking, it was not just the variety that changed down the age for data, but many factors that subsequently flourished with the passage of time. We will discuss them soon. So, based on the changes with time, data is categorized as traditional data and big data. Let's first understand what is traditional data. Traditional data is the structured data that uses centralized database management systems to store and maintain data in a fixed format in a file. Centralized database is a database that is located, stored and maintained in a single location. It is a quite old method of database management, but with the increase in the number of users on internet and spike in the amount of data being generated, they became slow. Traditional data is being managed by all type of businesses, from small to big. They are generated in enterprise level. The frequency of generation of such data is not high. That is, it is usually generated per day, per month or even more. Another important thing to note about traditional data is that, according to the modern standards, it's not too large in size. It is large enough to be easily managed and analyzed using traditional statistical tools. Let us understand it with the help of example. ERP softwares are used by various enterprises to manage and integrate the important parts of their businesses. An ERP system integrates areas such as planning, purchasing, inventory, sales, marketing, finance and human resource. Suppose you are a project manager whose job is to manage and update daily activities of inventory transactions into an ERP system. It is your responsibility to keep track of the goods moved, by maintaining the data of lot numbers, serial numbers, cost of goods, quantity of goods, and date and time of the transaction. Such type of data is generated within the enterprise. It is strictly private and better to be stored in a centralized database so that it can be easily integrated and accessed by project managers of other areas in enterprise. Such data is organized in a particular structure, that is rows and columns. It is sizable, manageable and is easy to be mined for relationships and patterns. Hence, data sources for traditional data includes ERP transaction data, CRM transaction data, financial data, web transaction data, etc. Let us now move on to next type of data in this categorization, that is, big data. Big data refers to an accumulation of data that is too large and complex for processing by traditional database management tools. There are many diversified definitions of big data in the market. Since the major technological boom from the dawn of 21st century, many big tech giants like Facebook, Google and YouTube have been able to rule internet and generate humongous amount of complex data. This data is not only large in size but also contain greater variety that is rich in information. One of the myth that floats among people is that what differentiates traditional data from big data is its size. This is not the complete truth. Surely, with the passage of time the amount of data generated had increased, but with it also developed our capability to store and manage large datasets. And more importantly, size is a relative factor. There is no exact amount of data to differentiate between traditional and big data. Then, if it's not the size, exactly what defines big data? The answer lies in how the data is used. The processes, tools, goals and strategies that are deployed when working with big data are what set it apart from traditional data. Oracle defines big data as the data that contains greater variety, arriving in increasing volumes and with more velocity. This is also known as 3 V's. These characteristics of data that if met is considered as big data. In recent years 2 more V's have been added to define big data more clearly. They are value and veracity. Let's look at these 5 V's one by one. First V is volume. If we see big data as a pyramid, then volume is the base. The amount of data obviously matters. More data inscribes more information. Big data deals with high volumes of structured, semi-structured and unstructured data. This data, especially unstructured, can be Twitter data feeds, clickstreams on a web page or sensor-based data. One important point to note is that for some organizations, big data can be of tens of terabytes of data, while for others it may be hundreds of petabyte. Second V is velocity. Velocity is the high frequency at which data is received and acted on. Companies need the incoming data to move quickly, preferably, as close to real time. Some Internet-enabled smart products today operate in real time or near real time, and will require real-time evaluation and action. Velocity can be more important than volume because it can give us bigger competitive advantage. Sometimes data have to be available at right time to make appropriate decisions. In such case, data at low speed can be hazardous. Third V is variety. Variety refers to the many types of data that are available. As we learned previously that traditional data types were structured and fit neatly in a relational database. With the rise in big data, data comes in unstructured and semi-structured data types, such as text, audio and video, that require additional preprocessing to derive meaning. Variety also refers to the arrival of data from heterogeneous sources, that is from new sources, both inside and outside of an enterprise. Fourth V is veracity. It refers to the inconsistencies and uncertainty in big data, that is available data can get messy, whose quality and accuracy may be difficult to control. Veracity speaks of the trustworthiness of the data. Lastly, fifth V is value. Finally, value sits at the top of the big data pyramid. This refers to the ability to transform a tsunami of data into a tool for profitable business. Bulk of data with no value is of no good to the company until it is converted to something useful. The ability to extract value from unstructured data is one of the main drivers behind the quick growth of big data. This is the most important V among the 5 Vs of big data. There is a lot more to learn about these 5 Vs of big data, which in itself is a separate area of study and lies outside the scope of this course. Moving on, there are dedicated platforms and frameworks to process big data. Nowadays plenty of these are available in the market such as Microsoft Azure, Cloudera, Google Cloud and Sisense. But one of the most popular among all is Apache Hadoop. Hadoop is an open-source framework that allows to store and process big data in distributed environment across clusters of computers. Distributed database environment is a collection of multiple interconnected databases, which is spread physically across various locations that communicate via a computer network. MongoDB, a NoSQL database, supports distributed database management and is actively used for big data and real-time web apps. Lastly, let's take a view on the benefits of big data. Big data makes it possible for us to gain more complete answers because we have more information. More complete answers means more confidence in the data, which means a completely different approach to tackling problems. Big data can help address a range of business activities, from customer experience to analytics. This brings us to the end on the second part of the tutorial on types of data.